So now we're going to look at the same example function. So that was y cubed over 4 minus y minus x squared over 2 that we looked at in the last clip. But we're going to, instead of graphing it by traces, we're going to graph it by looking at level surfaces. So a level curve or level set is going to be where, so the level set is the solutions of f of x, y equals c for some fixed value of c. Okay, so we might be looking at like, so for the level set with c equals 0, we would look at y cubed over 4 minus y minus x squared over 2 equals 0. And so now here's the rub. I actually chose an absolutely crap example for trying to graph with level sets because they're sort of crazy. They're not the usual curves that you're used to seeing. Most of them aren't even describable as a graph of a function. So let me bust out a computer to graph this for me. Okay, so there we go. So that's what the level curves of this function look like. So where c is equal to 0, for example, that this set right here, so this curve is part of that set. And then also somewhere over here, there's, let me see, where is it? It's this one. That's also the line along which f is equal to 0. And let's see what else. So there's one, so there's some crazy set right here along which f takes value minus a half, something like that, and connects. So that's where f is equal to minus 1/2, and so on and so forth. So the key point is not how do you come up with those curves, because I in the book will only give you examples of ones where you actually can crunch the curves. But what do you do once you have them? Okay, well, so let's see. So now we've got that one at minus a half that has the self-intersection. So let's see. So if this is x, this is y here, then what's this going to look like? So we've got the one that's going to have the self-intersection, and that looks kind of like this. And so now it is that's where f is equal to 1/2 or minus a half. So I need to sorry about that. I need to sink it down by minus 1/2. And then I've got the one where f is equal to 0. So that's where we had this one here, and then also this one here. And then there's one where f is equal to positive a half, and so that's like this. And so this is, it's supposed to be 3D in height above the curve that I showed before. And then there's also ones where it's further negative than minus a half, and so that would be something like this. And so I'm copying the curves from the figure that I had the computer plot for me. Now I'm just trying to put them in so that they're all at the right height. So this is where f is equal to minus 1/2, and this is where f is maybe equal to minus 1 or something like that. And then this is where f is equal to 0. And then this is where f is equal to positive a half, this little tiny one here. And so the idea is that if I were to draw the f axis in here, then all these curves would line up so that this one here would be up at height 1/2, and this one here, I'm sort of drawing these at a terrible angle. Alas, okay, my artistry is failing me. But anyways, you get the general idea. We're going to look at how to graph quadric surfaces in the next unit, and I think that'll actually make for much better examples of what's going on here. Let me just reiterate that these level sets can be thought of as traces as well. So if I bring back the graph of the function as we had it before, then you can see that if, what's a good color here? Maybe green. If we look at where, say, the value of the function is equal to 0, and so you can see it's actually even on the axis right here indicated as a 0, then where this plane intersects the curve, we have, so it's going to intersect it around like here and then there. And so then that's where that one comes from. And if you go a little bit lower down here to whatever, minus, I guess, minus a half or something like that, then you'll see that one that self-intersects right like that, something like that. And so that's the intersection with this, oh, that was a terrible plane, this plane right here. Level sets also give us a way to understand how to graph functions of more variables. So let's consider a different example now where we're looking at a function from R3 to R by f of x, y, z is x squared plus y squared plus z squared. Okay, so you might consider this as like, maybe this is a function that's giving the temperature distribution over some region of R3 or something like that. So now the issue here is that we have a dimension of 3 here and a dimension of 1 here, and 1 plus 3 is 4. And I don't know how to graph anything that's 4-dimensional. So that's not going to work for us, right? So understanding this by traces is not going to work so well, but we can still look at level sets. And so let's see. So let's look at where the set where f is equal to 1. Okay, so this is shorthand for saying this is the set of all x, y, z in R3 such that f of x, y, z is equal to 1. And so if I make that equation, f equals 1, then that corresponds to x squared plus y squared plus z squared equals 1. And I know what that looks like. It's just the good old unit sphere. Such as it is. Okay. And note that this unit sphere is the level set where the value f, where the function f takes the value 1. Note in particular that it is not a graph of a function, right, by itself. Let's also look at where c is equal to, let's say, r squared. Then we've got x squared plus y squared plus z squared equals r squared. Then this is going to be a sphere of radius r. Wow, my spheres are really going downhill today. It's a bad day to be a sphere. Okay. And I could also look at where c is equal to 0. So then I've got x squared plus y squared plus z squared equals 0. Now, how can that happen? Well, each of these terms here is non-negative. So the only way that this can happen is if x and y and z are equal to 0. So in this case, the level set is not a level surface. It's just a single point. It's just a dot. So And then we could also say, what is the level surface for -1? So x squared plus y squared plus z squared is equal to -1. Well, in that case, we go to graph the level set or surface, and we're like, oh, we're done. There it is. It's empty. There's no points in it, right? So the level set can be empty. That's an important case to be aware of.